Welcome back and thanks for tuning in. In today's lesson, we're going to be talking about the types of chemical reactions that we will be dealing with moving forward. So we've talked about chemical equations, chemical reactions, the evidences of those chemical reactions, and how to balance those chemical equations. So now we're going to talk about the types of chemical equations that we're going to come in contact with. Now, as most things in science, chemists like to classify things. We like to classify our reactions. Now, there are 5 basic classifications of chemical reactions that we're going to be dealing with. So, the first of those is a synthesis reaction. And synthesis is a very fancy word that simply means to create. So if you're going to synthesize something, you are creating something. So a synthesis reaction is a reaction that makes something new. It's identified by having 2 or more reactants, but only 1 product. So you have 2 or more reactants, only 1 product. Generally, the reactants are elements, but not always. Sometimes you can have compounds that will combine together to make 1 product.
For this reaction, we have elemental iron, and it's going to react with oxygen, which is going to be a synthesis reaction producing iron 3 oxide. So I'm going to use a battery to force that reaction with oxygen to occur. And so as it finishes, this is what it was originally. This is just the pure iron. And so this one is the iron 3 oxide.
So I want you to make sure you notice the color difference. That's a proof that the substance has changed.
The second type of reaction is a decomposition reaction. Decompose. To decompose means to break apart. So a decomposition reaction involves a compound coming apart, falling apart, coming away into different things. So it's usually identified as having only 1 reactant. So you're only going to have 1 thing on that left side of the equation and 2 or more products, 2 or more things on the right side of the equation. Generally, the products are elements, but not always. A single replacement reaction. These ones are fun, but they're a little bit more complicated. In a single replacement reaction, you have, as the name implies, a single element replacing another in a compound. So it's identified as having an element reacting with a compound to produce a different compound and a different element. So you can think about it as like stealing a boyfriend. So you have a couple over here and then a single girl over here who steals the boyfriend from the other girl, and now this one's single and this one is in the compound. So a single replacement is identified as having an element that reacts with a compound and it produces a different compound and a different element. All right, so for a single replacement reaction, we have here sodium metal. This is the element form. It's a nice silvery white soft metal, and we have a beaker of water. So sodium metal plus H2O is our reaction here. And see, it's producing a lot of heat. With the gas that's coming off is actually hydrogen gas being produced by the reaction, and the heat is igniting the hydrogen gas. So what's happening is the sodium is actually replacing the one of the hydrogens in the H2O molecule to produce hydrogen gas and sodium hydroxide. Single replacement reactions only occur if the element on the reactant side is more chemically active than the element that it's trying to replace. So to determine this, you have to look at the activity series. The activity series is a list of elements in their order of activity. It's on the reference sheet that is in the link below, or that I gave you in class if you're one of my students. So the activity series tells whether or not it can replace it. An element can replace anything that is lower than it on the activity series. So if it's below, then it can get replaced. If I have an element that is higher or lower on the activity series and I'm trying to replace something higher than me, I can't replace it and no reaction would happen. So make sure you look at the activity series to know whether or not a reaction actually happens. We'll get into that more in a later video when we talk about predicting the products of chemical reactions. A double replacement reaction, as the name implies, involves two elements replacing each other. Double replacement. So single replacement, you had an element replacing an element in a compound. A double replacement, we have two compounds that are going to switch partners to form two different compounds. So they're both changing. So think about it as we're just switching partners, like doing a line dance or a country dance, and you're switching partners.
All right, so for our double replacement reaction here, we have lead to nitrate and hydrochloric acid, and we're going to combine the two together. To make lead to chloride and nitric acid, and you can see that you can actually see a little bit down here. You can see it made a nice white precipitate. That's one of the hallmarks of a double replacement reaction that actually occurs, is you get an insoluble product or a precipitate.
So double replacement reactions typically involve products that are aqueous or dissolved in water. So that's how the reactions actually occur. We're going to have a aqueous, a dissolved substance that is dissolved in water, and we have something else that's dissolved in water, and when we mix them together, they are also dissolved in water. The reaction only actually occurs if one of the products is insoluble, meaning it does not dissolve in water. Otherwise, they just stay dissolved in water as ions floating around, and you don't actually have any net ionic difference. So when you have a insoluble product, you're going to have a reaction that actually occurs. To see this, we need to look at the solubility table, which is also on your reference sheet. And we'll talk about how to read that solubility when we get into the predicting of products. So to know whether or not a reaction actually occurs, you have to look at the solubility. If everything is soluble, if we have double replacement, you're going to have 4 compounds, 2 reactants, 2 products. If all 4 of those compounds are soluble in water, then the reaction doesn't happen. If one of those compounds is insoluble, then you have a difference in your ions, and so it would react. The last type of reaction is a combustion reaction. And a combustion reaction is a reaction that involves a substance reacting with oxygen to produce an oxide and energy. They always give off lots of energy. Now, there are different types of combustion reactions, but most of those combustion reactions could also be defined as either a single replacement or a synthesis reaction, like when a metal combines with oxygen is technically a combustion reaction, but an elemental metal combining with elemental oxygen to produce a metal oxide is also a synthesis. You have 2 elements combining to form one. You can have something where you have a compound reacting with oxygen. It's technically a combustion reaction, but that oxygen is releasing something else and releasing an element. It can be defined as a single replacement also. So since some combustion reactions can be identified as either a synthesis or a single replacement also, we're going to let those type of reactions always be synthesis or always be single replacement, even though they're technically also combustion reactions. But there is one type of combustion reaction that is only ever going to be classified as a combustion reaction, and that is a combustion reaction that deals with a hydrocarbon. Hydrocarbon combustion is always going to involve a hydrocarbon reacting with oxygen to produce carbon dioxide and water. Now, a hydrocarbon is a compound that is made up of mostly hydrogen and carbon, hence the name hydrocarbon. And it will have the general formula of CXHY. So you're going to have carbon combined with hydrogen in some form. So CH4, C2H6, those are all hydrocarbons, and they have a specific formula. Now, sometimes hydrocarbons can also have oxygen in them. So you have CXHYOZ would be the general formula, C3H2O2 or something like that, C2H6O2. Those are all also considered hydrocarbons. So what's called a hydroxyl group. A hydroxyl group would be the OH. So you can have something like ethanol, C2H3OH. And so that is also a possible hydrocarbon. So if you see anything like this, so basically you have carbon and hydrogen is a hydrocarbon. Now, since we did not learn the IUPAC naming for hydrocarbons, because that is a organic chemistry naming thing, and that's not something we're doing in this course, these will most likely always be given to you with the name instead of given to you in the IUPAC nomenclature thing. We'll give you the formula. So when you recognize those and they're being combined with oxygen, you should recognize that they are a combustion reaction. Now, regardless of the type of hydrocarbon, when it reacts with oxygen, the products are always carbon dioxide and water, always. They're the easiest ones to predict. And so when we talk about predicting, hydrocarbons are the easiest ones to predict because they always have the same product, carbon dioxide and water. Go.
This is the combustion reaction of ethanol and oxygen to produce carbon dioxide and water. So the products of combustion reaction are carbon dioxide and water, and you can see here there is water sitting in the bottom of my bottle.
So the generic equations are something you need to recognize. Generic equations for these types of reactions show us just letters, not dealing with any type of actual compound, but the generic equations show us what the reactions look like. So for a synthesis reaction, you have two reactants coming together to form one product. So the generic equation is A plus B yields compound AB. That's pretty simple. Decomposition reactions, you have one reactant that is breaking apart into its components. Now we're always going to deal with binary decomposition because the breaking apart of other things is going to be a little bit more complicated. So you have one reactant, AB, will produce A plus B. Notice it's breaking apart. Then we have single replacement reactions. So we have reaction A plus BX, element A plus compound BX is going to produce element B plus compound AX. So the A and the B, the cations replaced each other, switched places, and the anion was the same. Or you could have Y plus BX produces X plus BY. In this case, you'll notice that it's the anion. So you've got a negative element that is replacing the anion in the compound, and it gives you that. So you can either have the cations being replaced or you can have the anion being replaced. So those are our two generic equations for a single replacement reaction. With a double replacement reaction, we have AX plus BY will produce AY plus BX. So you'll notice that our switching of the elements. So the anions stay in the same order and the cations switch places. Sometimes you'll see the anions switch places and the cations stay in the same order. It's a matter of preference. It doesn't really matter. What matters is that you recognize that the compounds are switching partners. And then we have our combustion reaction. The general equation for a combustion reaction is going to be CXHY, so a general hydrocarbon plus O2 yields CO2 plus H2O. You'll notice that this is the only general equation that actually gives chemical element symbols because they're always the same. You're always going to have O2 yield CO2 plus H2O. The only difference is the subscripts for your hydrocarbon. So these are our types of chemical equations. You need to be able to recognize the type of chemical reaction off of just the reactants, because what we're going to be doing in the next video is talking about how to predict the products of these. So you identify the type of reaction based off of the reactants, and then you can use that to predict what the products are going to be. And that's really what chemists do, is try to predict the reaction, predict the products. So Hopefully you got that down. Thanks for watching and have a day.